Good afternoon, everyone. In this lecture series, we are going to discuss about the superposition theorem. In the previous video, we have discussed about the Norton's theorem. Now, what do you mean by superposition theorem means? Suppose if we are taking any network, the network should be bilateral and it should contain multiple independent sources. Here we are using the voltage or the current in any element that should be equal to the algebraic sum of the voltages or the current that should be produced by independent source. So this is the definition for the superposition theorem, and this is the diagram for the superposition theorem, how it consists of the multiple independent sources and the voltage or the current should be equal. Suppose if we are considering one source at a time, we have to off the other independent sources. So here we are having the voltage source, and the voltage source should be short circuit. The current source should be open circuit. The next thing, we have to find out the response, and finally we have to add the results at the end. So multiple voltage sources leads to confusion, and multiple current sources complicate circuit analysis. We are having the large number of equations that should be daunting, and we are having some of the steps. As I said that already already we have discussed about the Norton's theorem. We have to follow some of the procedure. At the same time, for the superposition theorem also, we have to see all the steps. We have to identify all the independent sources. We have to select one source, and it should keep it active, and we have to suppress, that is we have to turn off all the independent sources. Suppose if we are taking the voltage source, it should be replaced with short circuit 0 volt. Suppose if we are taking the current source, we have to replace with the open circuit. Then we have to solve the resulting circuit, and we have to find the desired voltage, and we have to repeat the independent sources. So here we are having the individual contributions, and we have to see the direction and polarity. This is a solved example of superposition theorem. We have to determine the current. So how much of the current is flowing through this 5 ohm resistor. For example, from the circuit, the voltage source is given as 10 volt, and again V2 is given as 5 volt. So the resistors are, that is 5 ohms, that is R1 and R2 will be 5 ohm, and both the sources are connected in a single loop circuit. Suppose if we consider the voltage, that is source V1 as alone, we have to keep 10 volt as active, and we have to replace this 5 volt. Now we have to calculate the current, that is I1 is equal to 10 by 10. Now the amperes will be 1. So the total resistance here we are calculating 5 plus 5 is equal to 10 ohms. In step 2, we have to consider V2 alone, and we have to keep 5 volt as active. So from the figure itself we can see, and we have to replace this 10 volt with the short circuit. Now the total current will be 10 ohm. We have to find out the current due to the voltage source V2. It should be in the active state. So already we have find out the value, that is 5, that is I is equal to V by R. Here we are considering the voltage as V, and the resistance value will be 10. So 5 divided by 10 is equal to 0.5 amps. The next step, we have to find out the total current. So as per the superposition principles, we have to add the current I1 and I2. We know that I1 is equal to 1 amps and I2 is equal to 0.5. Just we are going to apply in the formula, that is I is equal to 1 plus 0.5, we will get 1.5. So the current through the 5 ohm resistor will be 1.5 amps. While considering the superposition theorem, we have to know the definition. It is a linear bilateral network and there will be multiple independent sources and it will be the algebraic sum of the individual responses. So this is the definition of the superposition theorem. And here we are going to face some of the challenges in the circuit analysis. There will be multiple voltage sources and multiple current sources, and there will be large number of equations in the circuit analysis by using the various challenges. Suppose for example, if we take 5 ohm as the resistor, the voltage V1 will be 10 ohms and V2 will be 5 volt, and here we are going to find out the total current as 1.5 amps. Thank you.